So we will briefly discuss theoretically about the problem of measurement invariance, and then of course we would perform two examples of measurement invariance evaluation in the environment of JASP. So first of all, I would like to say that up to this time, every CFA we have performed was only one analysis for one group. So it means that the data files that we were using were treated as one group. But mostly in my data, I have more than one group, and my question could be, can I compare CFA, or in other words, we call usually CFAs also as measurement models. So can I compare these measurement models for different groups, and are these measurement models the same for different groups or not? The consequence of this question is that if measurement models or CFAs for different groups would be different, then these groups couldn't be compared. For example, if I go back into a previous example of left-right scale or conservatism, liberalism scale. So if, for example, the scale for left-right political orientation wouldn't be the same for men and women, it would be impossible to compare left-right political orientation for men and women. For example, if I would go on the ground of international comparisons, if the left-right scale would function in different style for Czech and Germany, Czech and German people couldn't be compared on left-right scale, etc., etc. That's why this discussion about measurement invariance, and that's why measurement invariance evaluation is so important to all of us. So now we would switch from previous discussion of only one analysis for my data file to many analyses. So it means different analysis for different groups. We call this style of thinking and model preparation as so-called multiple group factor analysis or only multiple group analysis. So in the next few minutes, we would be performing many analyses, different analyses for different groups, and we would compare these results. That's the main meaning of the evaluation of measurement invariance in a CFA. I would like to add that to evaluate so-called measurement invariance, it is also possible to use another techniques than CFA, but CFA seems as maybe one of the best options. So that's why we will be using CFA for this evaluation, but there are also alternative techniques that can be applied for this problem. So once again, my basic question is, can I compare model for different groups? Can I apply the same model for different group? And if the answer is yes, then I can compare results for these groups. That's very important. And if I try to evaluate this measurement invariance in CFA framework, so I'm usually using classical tools such as chi-square test, CFIs, TLIs, etc. Mostly, and that's why you have also available Cheung Rensvold article in Student Information System. These comparisons of different models for measurement invariance are based on CFI difference. And this recommendation for the CFI difference threshold was firstly published in Cheung and Rensvold article. So that's why we are using this article as a basic benchmark for our evaluations. Before we start to compute results, first of all, we would take one example together, and then I would assign you once again your own practice. So I would discuss briefly, theoretically, about 3 levels of measurement invariance. In literature, you can find more than these 3 levels, but these 3 are the most common. So that's why we would discuss about these 3 levels. groups. The first one would be called configural, and I would call it simply that it is expected that the same picture is expected to be applied for all groups. So it means the same picture, not the same loadings, not the same other parameters in the model. Metric invariance add to configural model also the expectation that not only picture should be the same for different groups, but also factor loadings should be the same. And in so-called scalar invariance, this is the highest level we would like to reach in this evaluation, is based on the logic that not only the same picture, the same factor loadings, but also constants that can be present also in these CFA models should be the same. So these are basic description of 3 levels, and now we would go through pictures that can help us a lot. So these pictures are from the article of Petra Nižová, which was describing comparability of Schwarz value portrait, which is a well-known measurement instrument for values. This article could be found in the Czech version of Czech Sociological Review, so sorry for students who are not speaking Czech, but still these pictures are very good, so that's why I would apply these pictures, and I would try to explain what is the meaning of these different measurement invariances. So it means configural, metric, and scalar. So first of all, for so-called configural invariance, it is expected that for 2 groups or more groups, if I have more groups, the picture would be the same. So it means I have 1 factor here, 3 indicators, and 3 random errors, and all parameters, so it means factor loadings, here some constants or variances for these random errors could be different for these 2 groups. So only the picture must be the same for both groups. So this is so-called configural variance, and this is the lowest level for measurement invariance. If I would like to compare some results between groups, I need to go further. At least I need to go to so-called metric invariance, and I would call it here as equality of slopes. So it means that these factor loadings, that's why you can see these ellipses here, must be the same. So not only the same picture for both groups, so it means 3 indicators here are describing some dimension behind, but it is also expected that this relationship between hidden dimension factor and between individual indicators must be the same. So that's so-called metric invariance. If this metric invariance is followed in your data, you can apply at least for these variables, so it means for these factors, regression analysis and compare regression analysis between groups. And mostly, we would like to compare the level of the phenomenon, such as left-right scale, conservatism, liberalism scale, etc., for different groups. And if you would like to make such comparisons, you must go up to the so-called scalar invariance. It is expected for this level that not only the same pictures are here, the same loadings are here, but the new property for scalar invariance is that also constants for different regressions that are present here must be the same. Up to this time, we didn't discuss about constants in structural equation modeling. We didn't need to discuss about this, as for classical and simplest models, we do not include constants or means into the computations. But if you would like to compare the level of the factor for the first and second group, you must include means into the computation and constants into the computation, and these constants must be the same. So that's so-called scalar invariance. And we would go to the next slide, and we would say that we would try to evaluate this measurement invariance by chi-square tests, but as far as we know, for CFA's models, chi-square is very, very strict, and it usually rejects our model, and it usually rejects measurement invariance as well. So that's why we would follow Cheung and Rensvold recommendation that if you compare different models, so it means model for configural invariance, metric invariance, and scalar invariance, if you go down by these models, you would take CFIs for these models, and if there would be a change lower than 0.01, then the biggest level of the invariance, which is called scalar invariance, is present in your data, and you can compare factor levels between groups. So it would be our task. For this first computation, I will open data for CESD8. So here we have the data for CESD8, which is a measurement of depressivity symptoms. This is the shortest instrument for measuring depressivity symptoms in social sciences. This CESD8 scale is the short version of original 20 items scale. So we would be using this simple measurement of depressivity symptoms. I would show you the questions that are behind this instrument. So I would go down. Here it is. Please indicate how many times during the last week you felt depressed, you felt that you were doing everything with exertion, you slept restlessly, you were happy, you felt lonely, you enjoyed life, you felt sad. It is 1, 2, 3, 4, 5, 6, 7, and the last one, you felt a lack of energy. These first 5 items are CESD8 instrument for measuring of depressive symptoms. So that's what we will be using. And before we start to compute results and to evaluate measurement invariance, I would go back. And if you read out these items, I guess that you can find that for these first 8 items, there are maybe 2 items that are quite strange in this scale. Can you help me to identify, let's call it strange items in this 8 item scale? What can be strange for these 8 items? Which items are quite different from the rest?
The items that you were happy and that you enjoyed life?
Yeah, thanks a lot. It is quite so-called reversed. And this reversal is usually based on the logic that if some respondent would respond automatically, you can recognize it as he or she maybe would answer not all at all or most at all for all the items, and it is improbable that you felt depressed for not at all or almost not at all, and you also for example, enjoyed life. So this is something like control of quality of answers. But for analytical reasons, we usually know that these items that are reversed are slightly problematic for data analysis. So according to the evaluation of this CESD8 scale, we know that if we would like to perform CFA for this model, we would take all these items, creating one factor. There are also some competing models with 2 or 3 factors, but we wouldn't go into these details. But at least we would take this item D and item F, so it is 4th and 6th items, and we would at least make the link for these random errors for these 2 positively oriented items. So we would take all these 8 items, but for the 4th, you were happy and you enjoyed life, the 6th one, we would take correlated errors. So that's only first insight which is necessary. So I would go to my data. First of all, I would change the definition to scales for first 8 items. So 8 times changing into scale up to the age. So that's the last one. And we have also 2 variables which are necessary here for gender and origin. So then we would perform measurement invariance, which would be comparing the model for depressivity for male and female. So it would be the next step. So first of all, I would like to evaluate basic model. So I would take these 8 items, and once again, I would need to correlate random error for you were happy and you enjoy the life. So I would go into factor, confirmatory factor analysis. And here I would take these 8 items and I would call this factor as CESD8. This is the original name. I would only add the relationship for 2 random errors. So D and F should be related to each other. So once again, it was D and F, you were happy and you enjoyed the life. So D and F, and I would only change a marker variable here, and I would add additional output for additional fit measures. So this will be our first evaluation of this model. And in a few seconds, we would get our basic results. So we are currently estimating basic CFA model for 8 items for the measurement of depressivity according to CESD8. And if you ask for additional fit measures, I can see quite good results. CFI 0.978, TLI 0.96, RMSEA 0.067 and SRMR 0.028. So it seems promising that in Czech environment, these are data from big survey on university students from the last May. So it seems that this model is quite good for the Czech students at universities as a whole. And currently, I would go back, I would be performing different models. So first of all, I would be performing model for male and female with the same picture. Unfortunately, in my data, we do not have only data for male and female, but there is also another third group, which is called as X, as some people decided not to assign to male and female group. So we would be comparing not only 2, but 3 groups at once. So I would take it as it is. So I would be comparing 3 groups. And my main question is whether for 3 groups, I can apply the same model. So it means the model with these 8 items related to each other and with one added link for 2 random errors for the first and the 6th item. So first of all, I would take this CFA solution and I would go into multi-group CFA. So I would be comparing comparison for different groups. You can see that by default, JESP will compute Configural, and you can change it to metric and scalar. There is also one more option, strict, but we do not discuss about this last option. So I would take Configural, once again, the same picture, not for 2, but 3 groups here, male, female, and X group. And I need to change grouping variable into gender. And if I change this computation, JESP would recompute my results very quickly and will evaluate whether I can apply the same model for this depressivity scale for different groups. Once again, male, female, and the group of those who didn't assign male and female group. So I can try to evaluate this model very quickly. So the CFIs, TLIs, RMSE, etc. should be the same as for basic model. So it seems probable that this configural invariance model can be applied to my data. So that's only first inside. And I can go very quickly to parameter estimates, and I can very quickly, for example, compare results for male group. For example, here 1, 0.7, 0.667, minus 0.7, etc. That's for male group. You can see that for the first and the 6 items, as they are reversed, these coefficients are with minus. That's expected. So I can take male group. Here I can take female group. So it seems that these figures are quite close to male group. And I can go also to the rest. Not the last one group is omitted from the computation. So we would be comparing only male and female. Sorry for that. X is defined as missing value here. So male and female group, and now I would go further and I would be comparing whether these factor loadings, once again, these results could be the same for male and female group. So currently I would take fixing of these values between groups to be the same. So first of all, I would copy the previous analysis. So I would call the first group as Configural. And the next level would be that I would be using metric version, metric MI. So I would need to go down into multiple group CFA, and here I need to change into metric invariance. So first of all, after the computation, I would need to evaluate the model as a whole. So first of all, I can see that CFI is 0.974, TLI 0.968, RMSEA 0.06, and SRMR 0.03. So it seems promising that this model, once again, expected the same loadings for male and female group could be possible to apply. If you go down to my results, so you can see that, for example, for these factor loadings for male, 1, 0.815, 0.669, and if you go down to female group, these must be the same as they are fixed in this model. And once again, the basic recommendation is, according to Cheung Rensvold article, let's take CFI and compare whether the change is lower than 0.01 between these two models. So I would go back and I would go to the first model. So here CFI value was 0.978, and currently for my next model for metric invariance is 0.974. And my question is whether the difference for these CFIs is lower than 0.01. Is it or not? 0.974, and once again here 0.975. Whether the difference is lower than 0.01, the question is. Can somebody help me to evaluate this difference? Are you still with me?
It is 0.0. It is low.
Yeah, as the difference real in my data is 0.001. So it is lower than 0.01. So that's quite good. So we can go further, and maybe we can also find the biggest level for us, so-called scalar invariance, that also constants would be the same. So I would ask for copy, first of all, of previous model. So once again, I will make a copy. I will ask once again for change of the title. So CFI for scalar level. Scalar MI would be computed here, and I would go once again into multi-group CFA, and here I would ask for so-called scalar invariance. So once again, JESP will recompute my results. We know about previous results, so we remember 0.975, 0.974 for CFA. So now we would compare new CFI for this last model. So I guess that in a few seconds, my computer will assign results. So here it is. And we can go down. And first of all, the overall evaluation of the model, CFI, TLI seems good. If I go down, also RMSEA is quite good. SRMR is quite good. So at least this model is not bad at all. And if I compare the CFI value 0.968 with the previous values, such as 0.974 or 0.975, which was the biggest value for the first configural model. So I can very quickly conclude that also this, I would call it the biggest or the highest value of invariance, scalar invariance is present in my data. What does it mean? It means substantively that if I would decide to compare the depressivity for male and female group, it would be correct comparison. So that's about measurement invariance and how you can perform measurement invariance in JASP. So this was our COM task. If there are some questions, so feel free to ask me just now, and then we would switch into your own practicing. Okay, so if there are no more questions, so I would switch only to my browser files, and now you should open the file which is called 11 MI Intel, which stays for intelligence. So this is a well-known data file from 30s, and these data are measuring 2 dimensions, dimension of some mathematical intelligence and some language intelligence. So here are variables for the first factor and variables for the second factor. So first of all, you should evaluate the model as a whole. So it means model with 2 factors. You should perform the model with 2 related factors. I can help you. And then you should take the gender variable, which is present in these data, and you should try to compare the model for boys and girls. So please, if you can take in the next 10 minutes this task. So first of all, prepare the model for 2 related dimensions. So here you have variables for the first one and the second one dimension, and then compare measurement invariance for all these 3 levels. So it means, once again, configural, metric, and scalar invariance, and evaluate these models. So I would only change the settings, and then you can start to perform